Now we have already seen one approach to loading the incremental data through SSIS, and that was through the use of the slowly changing dimension task that is available in the data flow task. Now today we are going to see two more approaches to do the same task. So the very first approach is using the lookup stage. So lookup stage or the lookup task, we have already seen that task. We'll just see how the ETL process design is when we want to use the lookup task to perform the incremental load. So I've added a data flow task called the incremental lookup, and I've renamed it to incremental lookup. This is a data flow task. Now, if I click on it and go to the data flow design window, I'll be able to see the design of this task. Now I can see what we are trying to implement over here is basically, as in our previous example, we have a dimension table, which is the dim employee table, and then we have some records in that table. The attributes are basically the primary key of the table, then the first name, last name, and then we have attributes called the title, email address, phone, gender, department name, start date, and end date. All right. So the start date and end date are basically to indicate the whether the record is a current record or a historical record. So if your end date is null, that means it is a current record. If your record is undated, that means it is a historical record, and there must be some current record for that person. Now, the keys on which we are going to check the records, the uniqueness of the records, are going to be the first name and the last name columns. So now here, if I see, I have this table and I've got some 20 rows in this table, and I have different values. I have some repeating records, and the end dated records and the current records, and so on. So I have different records, and then I've got my source data in terms of a flat file, and my flat file contains the same attributes: the first name, the last name, title, email address, phone, gender, and department name, and I have some values. Now, if we look at the data and the data in the flat file, we'll see the first record is Kevin Brown. So let's see if we have a Kevin Brown already in our table. So we have one record for Kevin Brown over here, and then we have an incoming record for Kevin Brown, and we can see that there is actually no change in data. So all the values are the same. He's a marketing assistant over here. Okay, so he's a marketing assistant. His email is the same. His phone number is the same. So nothing exactly has changed. So when we design our job and execute the workflow, this record should be ignored, because this is a record that already exists in the dimension table and none of the attribute values has changed. So this record should simply be ignored. Now the second record is David Bradley, and what is updated for him is his email address over here. So this is David01. All right. Now we have a David Bradley in our database, and he has two records, one historical records and one current record. And his email ID is David0, and we have updated the email ID. So this record should get undated, and we should get a new record with a new email ID. Now the third record is a new record, so it's a new insert. We don't have any record, pre-existing record for the employee Adam Owen. So this is a completely new record, and it should simply get inserted in a table. This is how our design should work. So going back to the SSIS designer, okay. Okay, so this is how our ETL design is looking if we are going to perform incremental lookup using the lookup transformation stage. So the very first step is obviously reading from the flat file. So we have seen this many times, how we can create a flat file connection manager, which has been created here, and then we are reading from the flat file called the employee data. So I have a flat file connection manager where I have defined everything, and these are my columns that I'm going to read. All right, and then and then I'm going to perform a lookup transformation. So this is my source data, incoming source data, and then I'm going to perform a lookup against the dimension table to check which are the new records, which are the updated records, and which are the same records as earlier. So I'm going to perform a lookup over here. So I've got a lookup transformation. I'm going to do a full cache, which is reading the entire data in the memory, and which will be very fast. And then in specifying how to handle rows with no matching entries. So if there is a completely new record, so it will not find any match in the dimension table. How do I need to handle those? I need to collect those records because I need to insert them records as completely new records. So I'm going to redirect them. So I've chosen the option to redirect rows to the no match output. All right. So they'll be redirected to another output, which I can then connect to my database stage to load that data into my table. Then I have my connection defined. Now for the connection, now I'm going to read from the dimension table all the data to see if there is a match in the incoming data. Now when I'm going to read the data from my dimension table, I already have some historical records in the table. So for example, if we go back to the table, we can see that for David Bradley, we have got 2 records. Now, when we are comparing the data with the incoming data, we should not be caring about the historical data. We should only be caring about the current data. So I want only the latest records from my dimension table, latest current valid records from my dimension table to be looked up against. That's why instead of reading the entire table, which would include reading the historical data as well, I'm just going to read the data, which is the latest data. Now, what is my way to identify the latest data? The way to identify the latest data is through the condition where end date is null. Okay. Okay, sure. I'm just formatting this. Our table is going to be the dim employee table. Okay. So let's go back and start from the beginning once again. Okay, so what is it that we are trying to achieve? Is basically we are trying to load data, incremental data, into the dim employee table. The dim employee table is a type 2 SCD table, or a type 2 slowly changing dimension, which means it has got historical records as well. For example, if we look at this person called David Bradley, then we've got 2 records for this person. One of them is end dated and one of them has an end date of null. Now, an end dated record means that this particular record for this person named David Bradley was valid. All the attribute values were valid between the date of 20th of July 2007 and 11th of February 2009. On 11th of February 2009 or on the 12th of February 2009, a change was made. All right. And there was a new record inserted for this person with some new attribute values, and that is currently the valid record because the end date is null. Okay. Now, if I make a further change to any of the values as I have for the email address of this person, I should be inserting a new record in this table. I should be end dating this record with the current date, and then I should be inserting a new record in the table with the current date, and the end date is null. That would imply that this is the current latest record. These are the current latest attribute values which are valid from today. Okay. So this is what basically we are going to achieve. Now for this, for doing an incremental load, we need some source data. So that would be a daily file coming in. For doing the incremental load, it could be at any fixed frequency, it could be a weekly file, it could be a monthly file. So we have got a source file over here, and it has got some data in it. All right. Some of the data in the file is completely new data. Some of the data in the file is already the existing data in the dimension table, but there have been no changes to the attribute value, so it should simply be ignored ideally. And then there's some data in this source flat file, which is data for the same person or the same employee, which already exists in the dimension table, but some of the attribute values have been updated. So since it is a type 2 dimension table, we should be undating the current record, inserting a new record with the new attribute values as are present in the source file. Now we have already seen there are different approaches for doing this incremental load. One of them is through using the slowly changing dimension task in SSIS, which we have already seen previously. Now we are going to see two more approaches today to do the same job. Now the first approach that we are going to see involves the use of the lookup transformation stage. So lookup transformation stage we are going to do a lookup with a dimension table, and this lookup is needed to identify the updated records and the new records which need to be inserted. So the records which need to be updated for the attribute values and the records which are completely new records and they simply need to be inserted. So the first step that we have done is read from the flat file. Okay. Same way, we have created a flat file connection manager. We have specified the file name, and then we are reading from the flat file. Simple. The next step is doing a lookup. Now for the lookup, we can specify any of the cache mode as we have seen previously. A full cache is obviously better, and we have a small table, so we've specified that so that the whole data is loaded in the memory and the operation is faster. Now I want to be able to collect the matching records as well as the not matching records. The matching records are going to be the one which are present in your source flat file as well as in your dimension table. So these matching records, they imply that they are going to be updated in the dimension table because they already exist in the dimension table. Now there are going to be some records which exist in your source file but do not exist in your dimension table. These are going to be your new records and they simply need to be inserted. So these can be identified by catching the no match output. So the no match output would basically be the output that would contain the records which are present in the source file but not present in the dimension table. So they need to be inserted into the dimension table. So we will catch those records as insert records. Now we have specified the connection. Now while specifying the connection and while performing the lookup from the dimension table, since it is a type 2 dimension table, we do not want to be reading the historical records because there's no point reading the historical records and doing a comparison. The comparison that we want to do is there a change in any of the attribute values as compared to the latest records as compared to what already exists in the dimension table. All right. So now to identify the latest records, we have to include this condition where end date is null. Because all the historical records would be end dated, all the latest current records would have the end date as null. So we have included this condition where end date is null. So we had an option, we could have gone over here and used any of the table, read directly from the table. If we would have read directly from the table, then we would have been reading all the records and we would be comparing across all the historical records for the same employee, which we do not want to do. That's why we have taken an option to use the results of a SQL query instead of reading directly from the table. And then we have customized the query as per requirements by adding this where condition, where end date is null. Okay. Now, when you have all the columns, the thing that you need to do is basically connect between your key columns. So the columns on which we are going to identify the uniqueness of the data or the uniqueness of a record, or which are basically the key columns in our data, are the first name and the last name. So simply connect the first name and the last name column. So the lookup would be performed in the first name and the combination of the first name and the last name column. And this is exactly what we want. Okay. No advanced properties we need to set, no error output we need to set, so we can just say okay. Now, the way we have configured the lookup transformation stage or the task, there would be two outputs coming out from it, the match output and the no match output. The match output is obviously the output which implies that the record exists in the source file as well as in the dimension table. So if it exists, then we simply update in the dimension table. The no match output implies the data that exists in the source file but not in the dimension table. So we simply insert in the dimension table. Now going back to the data, which is actually the update data for the dimension table, if we simply go and update all the records which are matching in the source data as well as in the dimension table, a lot of records would be updated wherein we do not genuinely want to or need to update those records, and those are records which are unchanged records. For example, in a file, in a source file, the first record, which is this record. Now this record already exists in our database as well. Okay. And if we compare the attribute values for all the columns, like the title, the email address, the phone, gender, department name, etc., then they're exactly the same as they exist in our source file. So we do not really need to update this record, because if we do, then there's a lot of database operation and processing involved, which would add additional processing time to our ETL job. Now, for example, we have only a limited number of records, but in actual data warehouse production environment, there might be thousands, 10,000s, millions of records. And if we choose to update all the records, that is going to waste a lot of database processing time. So we do not want to do that. We actually want to genuinely identify which are the records which have any change in the attribute values. So going back to the design, what we need to do is add an additional lookup. Okay. Now I have already identified the records which are update records, or which are present in the source as well as the dimension, so they need to be updated. Now I'm going to refine my filter to identify only those records out of those updated records which have a genuine update in any of the attribute values. So what I'll do in this lookup transformation task is again perform a lookup, but this time I'm going to perform a lookup between all the columns in my table. So if any of the values has changed, now if any of the value in any of the attribute has changed, it would be identifying the incoming record as a new record. Okay. And that is a record that I want, because that is a record that has a change in the attribute value, and that is a record that I want to update in my dimension table. So I'm going to filter my updated records to those records which have a change in the attribute value, and for that I'm going to perform a lookup between all the key columns. So if any of the value, for example, the title had changed, for example, let's say the title would have changed. So if the title does not match the title in my dimension table, then the match would fail, and that record would be collected as a record, as a non-matching record. So now I'm going to, after this lookup transformation stage, I'm going to collect my no match record. Okay. So here I have collected, as you can see, my no match output. Now, once I connect my no match output, then I have generally identified the records which have a change in the attribute value, and those are the records I'm going to go and update in my dimension table. Okay. Now let's go back over here to the new records which we had identified. So the new records were the ones which did not exist previously in the dimension table, and we need to insert those records. So now I have those down my lookup no match output link from the first lookup transformation stage. And here I have my update records. Now I'm going to use another transformation called the multicast record. Now, what are the operations we need to perform for the update records? There are two kinds of operations that we need to perform for the records which we have identified as update records. Now, going back to the table, what are those two kinds of transformations? Those two kinds of transformations are basically, for example, this record. This is my record, which is my current record in my dimension table. Now I have another record coming in from the source and I want to be updating this record. Now since it is a type 2 dimension, I do not want to be updating the same record. I want to end date this record by putting a value over here and insert at the same time insert a new record with the new attribute values. So two kinds of operations are involved here. One is updating the already existing record in my dimension table with an end date, and the second operation is inserting the new record in my dimension table. So again, two operations, update and insert. Now, using this multicast transformation basically can split your input stream of data into multiple output streams. So I can have any number of streams coming out of it. So now I'm going to collect that data that is coming out from my multicast transformation into two streams. For the one stream, I'm going to just take it to an OLADB command, that is again a transformation stage wherein you can execute a database command. So now for the updated records, I have taken them to my OLADB command and I'm going to run a database command, which is simply, if you go to component properties, you have an option to write a SQL command over here. And I'm going to just click on it and write a SQL command when the simple operation that I'm doing over here is update dbo.dim employee, which is my dimension table, set end date as get date. Okay. So get date will basically bring out the current date. So that's a SQL Server database function. So end date is get date would be the current date, where first name is equal to question mark, last name equal to question mark, and end date is none. So all the currently existing records in the dimension table would be end dated. So because I'm setting the end date over here. And how am I identifying those records? By the first name and last name. And these are the question marks. What are these question marks doing? They are simply passing your parameters values from your incoming stream. So if you go over here on the column mappings, you will see that there are two available columns called param 0 and param 1. So these question marks get converted to param 0, param 1, param 2, and so on over here. And then you need to map your input column to those parameters. So we said your first name is equal to question mark. So to the first parameter, I need to map my first name column. And we said the last name is equal to another question mark. So to the another parameter column, I need to map my last name. Okay, so simply map them correctly over here and say okay. So this would execute an update command wherein it would identify all the update records which currently exist in your dimension table and end date them, update their end dates with the current date. So one operation performed for the update records. There's another operation that needs to be performed, which is inserting the new record. So inserting the new record, simply again I have used the multicast transformation over here. So I've taken another output stream with the same records. And now I'm combining because they are also insert records and the new records which we have identified are also needing to be inserted into the dimension table. So now we have two streams of data which need to be inserted. So I'm going to combine those streams using the union all, simple operation. Okay, union all, just put in union all. It would have the same structure of the incoming data. It would combine your data. It's like a union operation in your SQL database. Once I have performed my union all operation, then I need to set my start date. Okay. Now the start date should be the current date or whatever you choose. It could be +1. Okay. So I'm going to use a Derive column transformation. A Derive column transformation basically allows us to add additional columns with derivations in it or with calculations on it. So I'm going to use the Derive column. And what I'm going to do over here is derive my start date and end date. So start date I've added as a new column. My expression is simply get date. okay, and it's a database timestamp, simple. And then I have derived my end date value, which is going to be null because these are going to be the current records. Okay, okay. And now this is a simple insert operation. I have all my input data configured with the values, so I'll use an OLADB destination stage instead of an OLADB command. And why we need to use the destination stage, we could have used the insert stage, the command stage as well. But the command stage in the SSIS performs operations row by row. So it is a slower stage. So wherever we can, we should use alternate task transformation stages. All right. So here we can use an OLADB destination because now it's a simple insert into the dimension table. So double click on it and simple select your table where you want to insert. It's a fast load, and we will select the dim employee table. Okay. Mappings would already be there. If they're not there, then you can just drag and drop and do your mapping and say okay. Okay. So this is basically how you would design your data flow using a lookup transformation. Now let's go back to the control flow and execute this data flow task. Okay, and then we can see the results in the dim employee dimension table. So a green question mark means it has executed. We can go to data flow and see what exactly has happened as well. Okay, so there were 3 rows to the match output, 2 rows went, and no match output, nothing went. 1 row came here using all Derive column, 1 row, and then it got inserted into my destination table. Okay. Okay, just a second. Because this is dim employee 4, this should have been dim employee. Okay, let's change the table name once. Okay, come out of the debugging mode. Go to Lookup Stage, go to Connection. Let's make it dim employee 1. Go to Lookup 1, Connection. Let's make it dim employee 1. OLADB command. Let's make it dim employee 1 and destination. Let's choose dim employee 1. Okay, going back to the control flow. Okay. Let's close this. Say yes. And open this over here. Okay, and we'll re-execute. Let's check our dim employee 1 table meanwhile till this one opens. Okay, so this is the data in our table. So same data I've replicated across different tables so that it's easier. It's still opening. Okay, so this is one way we'll be executing it and we'll be seeing the results. And then another approach that we are going to see for the same incremental load is going to be using the merge join transformation. So we had seen that transformation earlier on, and we'll see how we can design the ETL process using the merge join transformation. So there are different ways of designing the process. They all have their advantages. They have which one is easier to maintain and so on. And the third operation is always to do it through your SQL if you can, which would be the fastest approach because the databases are the fastest in terms of processing power. So if you can write a query and execute it in your database, that would be the fastest. Okay. Lookup, as we said, lookup has advantages where the dimension table can fit into the memory. So if you can perform yeah, I'll do that. Let it first open. I'll do that. Okay. Okay, as I was saying, the lookup transformation has the advantage where you can you have a small dimension table and you can fit the entire dimension table into your memory because then your lookup operation would be faster. Otherwise, you can go for the merge join, which would be able to do a lookup kind of operation on tables which are not big enough, which are uh, like bigger than can fit in the memory. So for those, we can see the merge join operation, and that's easier to that involves lot less tasks or stages, so it's easier to maintain later on and understand as well. Okay, it's taking some time to load. Okay. Okay, so for some reason that's not loading. That's fine. Let's leave it over there. So this is your incremental lookup. Let's go back and change the table name again if you want to see the results. Let's hide this window. Hide. Okay. Lookup. Just going to change the table names because I've already used these tables for the update, so you'll not be able to see the results. So we're dim employee 1. Okay. Lookup 1 also will refer to the dim employee 1 from dim employee 1. Then in OLEDB command, we have to go to component properties. This is the query that you wanted to see. This is where we are setting the end date through the query for the records which need to be updated. So it's basically update the table, set end date equal to get date, the current date, or you can set it any way you want, where first name is question mark, last name is question mark, and end date is none. And then in the column mappings, map those question marks, which would be converted into parameter values as 0, 1, 2, 3, 4, so on. Map them to your columns. Okay. Facing that query in the chat window as well. Okay, and OLEDB destination, simple. We are going to change the table. We are going to do a complete load. This is 1. Okay. And for the insert records, we have set the values over here. Start date, end date, start date. So it's going to be a new column. So we have just typed in, okay, like start date. Just type your column name and then, okay. In your expressions, you can use any of these functions. So if you go to date time functions, you'll see that there's a get date function, which you can use over here. Then for the end date, because we want to set it to null, and it needs to have a timestamp of database timestamp. So go to null functions, and you can find this function. You can find null for all kinds of data types. So we want it to be timestamp, so we can find it over here. Okay, this is the function that I've used. You can see the control type text returns a null value of a requested data type. All right. So for any kind of data type that you have in your table, you can return a null of that data type. Okay. 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 Okay, just cancel it over here. Okay. Now save it. Go back to the control flow because we want to execute only this task. Right click and say execute task. Okay, green check mark means it has executed fine. Let's go back to the data flow window. So now you can see that it read 3 records from the flat file. So there are 3 rows coming over here. Then it performed a lookup with the dimension table. When it performed a lookup with the dimension table, it found 2 records which were already existing in the dimension tables. So it identified those 2 records as the, okay, let me change this, my control to this. Okay. So it identified 2 records as update records, and it passed them out to the lookup match output link, which we'll collect as update record. And then it identified 1 record as a completely new record, so we'll be inserting that record. Then we performed another lookup operation to identify the records which had any update in the attribute values. After that, we identified 1 record. So you can see 1 row over here. So it identified 1 record over here. And then for the update records, we need to perform 2 operations: update the already existing record with an end date and insert the new record with the end date of null. So we use a multicast transformation. This 1 row flows over here, combines with the insert record and becomes 2 records. So 2 records would now be inserted in your table. And then over here, 1 row comes in for the update record, and this is an OLEDP command which is used to update the data or end date the currently existing dimension record. Okay, so now question is, so there is no start date here over here. So what I have pasted in the chat window is for the update command or the update records. So the records that you're going to update, you're just going to end date those records to indicate that now they are historical records, and then you're going to insert the same record for the same set of keys, which is the first name and last name in our case, with an end date of null. So this operation over here is just end dating the already existing records. To end date the already existing records, we do not need the start date. The start date remains as is. Okay, we just end date those records by putting an end date value as get date. As get date, we are doing it in our case. If somebody wants to put some other value, then they can put some other value as well. All right. For the start date and the end date, for the new records which we are going to insert, we are going to put a start date as the current date and end date as null to indicate that they are current records. For those records, we have used this derived column transformation, and we have derived our start dates and end dates. So start date as get date, which is the current date, end date as null to indicate that this is the latest record now. Okay. Now if you want to check in a table, this is a dim employee table. Let's execute the query once again. We can see that there are 22 rows now. Now we said that for this person, David Bradley, there was going to be a new record, and you can see surely the latest record as it existed earlier has been end dated with today's date, which is 22nd of June 2019, and a new record has been inserted for this person with a new email ID. You can see that this is a new email ID with 01 over here, and the start date is get date, which is the current date. This is how we specify it, and the end date is null. So now this specifies that for this person, David Bradley, this is the current record as valid from today. We want to look up any value earlier than today, then we have to go to this record, because the second record was valid between the 12th of February 2009 till today, and from today itself, this particular record is valid. Okay, now you can see that for the earlier existing end date records, the end date was 11th of February, the start date was 12th of February. So you can design your job this way as well. We have taken them to be continuous, but what you can do is you can add +1 day, or you can end it as -1 day. So I could have end dated get date -1 day. So this would have been 21st of June. Okay. So anyways you can do. It's your preference in the project. Some people want to keep it continuous, so they'll be using the same dates. Okay. So for this particular person, two operations were performed. The old record was end dated, so where we use that query to set the end date to the current date, and then a new record was inserted for the same person with the start date as the current date and the end date as null. End date as null always specifies, in our case, that this is a current record. For some other data warehousing projects, they might have a standard of setting the end date to some maximum value, like 2099, 12, 31, something like this. Okay. Many projects will set the end date to a value like this, because this is going to be a max date and this is going to be true in a long while. So all the records which have an end date of this value would be identified as the latest records. For our case, in this example, we have set the end date to none. So it's all on the project design. So this record has been inserted. This was a new record altogether for Adam Owen. So this has been inserted with the start date as today's date and date as null. And then for this person, Kevin Brown, the record existed in a source file, but there were no updates to any of the attribute values. So there has been no change to this record. Okay, so now this has worked as expected. This has properly updated your type 2 dimension. All right. So this is basically how you can design your job using a lookup transformation for a type 2 dimension. Okay. So the simplest approach is still to use your slowly changing dimension stage, because you just need to configure, you just need to specify your primary keys and so on, and it will design your job on its own. But if there are some complicated operations involved, for example, here we have just performed a start date and end date, so you want to do more derived columns or something, then you can go for the lookup transformation stage. So this is basically a design that has more scope for customization as per your project design. But if it's a standard design and it can be implemented through the slowly changing dimension task, which can also be customized to an extent, then you can use a slowly changing dimension task, because that's a very powerful task, and that allows SSIS to do a lot of work for you, because it will design the backend data flow for you. Okay, here you have to design everything on your own. But it's easy, simple step. Read your source data, do a lookup with your dimension table, identify the matching as well as not matching records. The not matching records are going to be your insert records. The matching records are your update records. Then do a further lookup on all the columns which you want to see the change, identify the changes for, and then you can identify any records which have a change in any of the attribute values. Then go and perform an update and date those records, and then at the same time insert a new record with the new attribute values, and insert the new records as well. Okay, so this is one of the job designs. You can take a look at the video later if you have any doubts from today's class. Then take a look at the video a couple of times and try to design it yourself using a simple example. As I said, the best way to practice is to download the AdventureWorks database. Okay, so I've simply copied the tables from the AdventureWorks database to my own database, and I have limited the number of records to be able to show the examples clearly. So copy some of the tables. The dim employee table is available in the AdventureWorks data warehouse as well. And then you can uh, copy that table, delete a number of records, keep like 10 or 20 records, and then design. You can have your employee data like this. So I'll share this file as well with you, and then you can just design this data flow. Okay. Okay. Yes, so you should go and try creating this data flow from scratch. Okay. Try doing that. It will take you some time, but once you're done with that, then there would be no doubts. Okay. Then even for the next design that we are going to see, you'll be able to understand. So it's only the first time, and then it would be all clear to you. So try designing it. If you have any questions, ask me tomorrow in tomorrow's class. Okay, try to do this. We'll see another design as well using the merge transformation, and then it will make more sense to you. And once you do try to do it yourself, you can do it. As I said, use the same tables. Download the AdventureWorks data warehouse database. I'll share the input source file with you, so it will make it easier for you. Okay, so you can use the same source file and try to do the same operations. Okay. Okay. So go